Hello again, students. This is lesson 5-6 on page 357. We're going to be learning about parallel and perpendicular lines. And let's take a look. Okay. 5-6, parallel and perpendicular lines. Okay, but before we go into the lesson, I again want to review the forms because you're going to need to know them. All right. So far I've forced you to learn 6 different forms of the linear equation. Form number 1 is the slope form, which is y2 minus y1 is equal to x2 minus x1. The second one is direct variation, which is y is equal to kx. You'll notice there's no plus or minus anything on that one. Instead of using the value m, we use the value k as the coefficient of x. However, they really are the same number. It just depends on what you're doing with it. If you're looking at how it varies, then you would call it k. If you're looking at it as slope, you would call it m. Number 3 is the parent forms, which are y is equal to x or f of x is equal to x. Question, or not question, but type 4 is the slope-intercept form, which is y is equal to mx plus b. And again, we use m there to represent the slope, and b represents the y-intercept. Number 5 is the point slope form. Y minus y1 is equal to m times x minus x1. Okay, and then the standard form, which you just learned, which is ax plus by equals c. All right, I hope that that's very clear for you. Please have those memorized by the time we take the test. All right, going into parallel and perpendicular lines. Sometimes you may have multiple lines on the same coordinate plane. That can be for various reasons. Now, if you are graphing information, that information may be written in 2 different lines. Like one line is the amount of financial growth in the first quarter, and then the next one might be the second quarter, and you're comparing them. Again, that's a very business-oriented way of thinking about it. But for whatever purpose that you have more than one line, it does occur. So here's a coordinate plane where I have a red line and a black line. And as you can see, these 2 lines cross. Here's another coordinate plane, same color lines, but these ones are not crossing. But I want to ask you the question, are they going to cross? Evelyn, that's right. If you were to follow both of these lines off of the paper here, at some point they're eventually going to cross, probably right about here, I'm thinking on the edge. But yeah, so any 2 lines that are on the same plane, even if they are very far apart, eventually will cross unless they have this specific definition, or they're called parallel. Let me bring this down so you can see these other 2 lines. Okay. So these 2 lines here are called parallel lines. Now parallel lines, as you can see, are both going in the same direction, kind of like train tracks. Now if you had a train and you were riding on it, hopefully the tracks are both going to be going in the same direction. If they were to turn, then that would cause some type of a damage to the train and everyone that's on board of it. Okay? And then we have perpendicular lines, which makes a cross. Now the idea of perpendicular lines is that both lines, when they cross, they make the same size angles or square angles on all sides. Okay? Where this one, if you look, you'll have 2 really wide angles that are made, and you have 2 really narrow angles that are made. Okay? The perpendicular, all of the angles are the exact same size, and they all would make the edges of squares. So let's take a look at some more information about parallel and perpendicular lines. Okay? Parallel lines have no common points. They're on the same plane, but they're always going in the same direction. Since they're always going in the same direction and they are separated from each other, then the 2 lines will never touch. Kind of like we said with the train track. If the lines in a train track touched, the train's going to crash. Okay? So, but there's something implied here. Since these lines are going the exact same direction, then that implies that they have the exact same slope. Now, you might be like, slope in a train track? But again, train track is just to help you understand parallel. But going back to graphing purposes, we want to think of what is the slope of these lines. Okay, so my rise is 1, my run is 1, rise, run, rise, 1. So the slope for that line would be 1 over 1, which equals 1. Let's take a look at the red line. Rise, run, rise, run. Yep, they have the exact same slope. Okay. Now, I've jumped from the idea of train tracks to slope just because I'm wanting to remind you that what we are doing is, working on slope, one of the most important concepts when you're dealing with linear equations. Okay. So having said that, we can see that when two lines are on the same coordinate plane that they have the exact same slope because they're going the same direction. So how does that work when you have an equation? Well, whatever value for m in your equation, remember y equals mx plus b, is going to be the same, okay? A large part of dealing with linear equations is dealing with how is this going to look in the graph and how is this going to look as the equation. Now let's take a look at perpendicular lines for a minute. Perpendicular lines have a common point and they make the same size as square angles as we pointed out before, but there's an implication here. They are opposite of parallel, okay? Now, you'll see that parallel never cross, but perpendicular crosses exactly square across the other line, okay? It's not like these two lines where they're almost parallel and a long ways down the line they'll eventually cross. It's not like that. They are the exact opposite of parallel. Okay? So the word opposite here is kind of an important idea in dealing with parallel and perpendicular lines. I'm going to pause for just a second. Hello, I'm back. I just needed to check on a couple things here. Okay, continuing on with our lesson. So we have these two graphs. We have two lines that are parallel and two lines that are perpendicular. So before we do some problems, I wanted to show you some information about these. Now we already determined that these ones had the same slope. But if I were to write them in equation form, I'm going to go ahead and start with y equals mx plus b. Now, even though we have standard form and point slope form, slope-intercept form is usually the easiest to use. So that's kind of the go-to form. So whenever you're trying to translate this into this, that's going to usually be the easiest one to start with. Why? Because it just gives you so much information. So let's start with the red line first. Okay, let me grab my red pen here. So looking at the red line, we know that the slope is 1. So I'm going to go ahead and write a ghost 1 here. Okay, and B is the y-intercept. So where does it cross? It looks like it crosses right here at 1. So y equals 1x plus 1. There we go. There's the equation for the red line. Now let's take a look at the black line. Okay. Now we know that the black line has the same slope, the ghost 1 there. I call it ghost 1 because you never write 1 when it's the coefficient of a variable. Anyways, so continuing on, so we know that that the slope is 1 over 1. Now let's find the y-intercept. So go down the y-axis, and it looks like it's here at -2. So y is equal to x minus 2, or y is equal to x plus 1. So there's the equation for both lines. Okay, and again, you don't have to write the ghost one. I just put that there so we can fit it into the form so that you have something there for m. Okay, but you'll notice with the perpendicular lines that they are opposite of parallel lines. So that's like extremely important that I say opposite. So let's go ahead and make an equation for each of these lines. And again, we're going to start with y equals mx plus b. Okay. Actually, I'll do it down here so we're looking at it in comparison to the correct. Now, let's take a look at my first line here. In my first line, it crosses the y-axis at 0. Okay, so we'll put plus 0 for plus b. Now, let's take a look at the slope. Rise is 1, run is 1, rise is 1, run is 1. So 1 over 1. So y is equal to 1x plus 0. Or basically in this one, this would be just like the parent form, y is equal to x. So that's a fairly simple equation, but in simplest form, you could write it as y is equal to x. But if you wanted it in slope-intercept form, it's y is equal to ghost 1 x plus 0. Okay. Now, let's take a look at the black line here. Okay. So it looks like it crosses. Oh, hold on. Let me switch to the other pin. Looks like it crosses the y-axis at positive 1. So my value for b would be positive 1. So remember, b is the y-intercept. So put y equals. Now, let's take a look at the slope. So its slope is negative, okay, because it's going down from left to right. So let's take a look. 1 over, 1 down. Or I should probably say 1 down, 1 over, 1 down, 1 over. Rise over run. So that would be negative 1. So I would write it as y is equal to negative 1x plus 1. So, if you look at them, the slope for the red line is positive 1 over 1. Oops, sorry, 1 over 2, 1 over 1. For the black line, the slope is negative 1 over 1. Now, in reality, with perpendicular lines, the slope for the perpendicular line is going to be opposite and the opposite value, so meaning that it's in this case opposite of would be negative as opposed to positive, and it would be the reciprocal of, meaning that whatever your numbers are going to be flipped. Now, I probably should have picked a better example because 1 over 1, if you flip it, it still looks like 1 over 1. But the idea is that these two numbers um, are flipped. So the rule for perpendicular lines is that they are opposite reciprocal of parallel lines. I don't think I wrote that where you can see it. They are opposite and reciprocal in the slope of a parallel line. So what does that mean? Let's just say, I'm just going to make up an equation here. Y is equal to 1/3 x plus 4. Okay. A parallel line, a perpendicular line would be y is equal to -3 over 1x. We'll just say minus 8. I'm not so concerned about what the value of b is, or the y-intercept. I'm mainly focused on the fact that your slope is going to be opposite. This one's positive, so this one will be negative. Reciprocal. This is 1/3, so this will be 3 over 1. Now, generally speaking, when you have a number over 1, you would write it as a whole number. So you would write it this way: y is equal to -3x minus 8. Okay, in a case like that. So my point being is that if the reciprocal of a fraction is sometimes going to be written as a whole number. -3 is equal to -3 over 1. I'll draw a little ghost version here, just showing, okay? Now, I have some problems for us to do. So let's take a look. And these problems are also in the book, starting at page 357. I think they're on like the next page or next 2 pages. So let's go ahead and take a look at the problems. I'll just move myself over here. Okay, so I have an equation. Y is equal to 2x plus 3. I have a question. I have a parallel line containing the point -3, -1. What would the parallel line's equation be? Okay, so the line that I have is y is equal to 2x plus 3. The point that I have is on a different line, -3, -1. What I do know is that the different line is parallel. Let's figure this out. Start with what we do know to figure out what we don't know. Okay? Here's what we do know. We know that the line is parallel, and we know that parallel lines have the same slope. Okay? So if they have the same slope, then the parallel line is going to have a slope of 2. Now, I've written a form here. Y minus y1 is equal to m times x minus x1. Remember what that form is? Yep, Esau E, you're correct. That form is the point slope form. Well, let's look at what we have. We have a point and we have slope. So the point slope form is probably going to be the easiest one to use. Okay, so now I know that they're parallel, they have the same slope. Parallel equals having the same slope. So therefore, the letter for slope is m. I can substitute the slope from the original line and place it there. Okay. Now, I'm going to write the rest of the form here. Okay. So I have my y value is -1. Oops, I forgot to write the equals here. Let me do that. Now, since that's -1, I can either write it as y minus -1, or I can write it as y plus 1. And my x value is -3, so I can either write that as minus -3 or plus 3. So my equation would be y plus 1 is equal to 2 times x plus 3. I substituted in the point. Now again, and I can write this to keep it in form, I can write it like this. Okay, to keep it in form, I can write it like this, minus -1 or minus -3. But since both of these are negative, then they can just combine with the minus sign to turn to positive, or the negative cancels out the minus. Either way, that would be your answer. Now, let's say I want to put this question into slope-intercept form so I can compare it to this line here. Because like I've said over and over again, slope-intercept form is the easiest one to use. So I'm going to rewrite this version of the equation. Y plus 1 is equal to 2 times x plus 3. So all I have to do then is isolate the y and simplify the rest of my equation. So I'll do that. First I'll distribute. 2 times x is 2x. 2 times 3 is 6. Y is still not isolated, so let me subtract 1. Now it's isolated, but I have to do it to both sides. Isolate opposite both. So I have 2x plus 5. Y is equal to 2x plus 5. And there's my equation in slope-intercept form. Okay, let me review the steps. I have an equation. I have another line that's parallel. I don't know the equation to the parallel line, but I know a point that's on that line. Using point-slope form, I can substitute in the slope, 2, and I can substitute in the points, -3 and -1, to get an equation. Now that I have the equation, I've almost solved the problem. But to put it into slope-intercept form, all I have to do is take my equation and isolate y by simplifying it. I simplify by distributing here, and I end up with y plus 1 is equal to 2x plus 6. By isolating the y, then I end up with y is equal to 2x plus 5 by subtracting 1 from both sides. Okay? Now you notice I didn't subtract 1 from 2x here. I technically subtracted 1 from this entire side of the equation, but since 1 is like terms with 6, then I just subtracted it from that. And then by default, then it's automatically subtracted from the 2x because it's subtracted from the 6. And 2x plus 6 represents one number. Okay? Let's take a look at problem 2. Are these lines parallel, perpendicular, or neither? Okay? So I have 4y is equal to -5x plus 12, and I have y equals 4/5 x minus 8. So this one is in slope-intercept form, the form we like. This one is in standard form. I'll just put stand for standard. Yeah, the writing is terrible sometimes. You probably know that by now. Okay, anyways, enough about my writing. Let's go ahead and we can solve this particular problem. So the first thing I want to do is I want to put them in the same form to compare them. So what form am I going to do? Am I going to change this one to standard form, or am I going to change the standard form one to slope-intercept? Remember, slope-intercept is always your go-to unless you're instructed otherwise. So I'm going to change this to slope-intercept form. How do I do slope-intercept form? All I have to do in this case is isolate the y. Okay, so to isolate the y, I do isolate by opposite operation, multiplied by 4. The opposite is divide by 4. Now y is isolated. But I haven't finished unless I do this to both sides of my equation. Now, you noticed when I applied 4 to the other side of the equation, I did it to both numbers. Because when you multiply to both, you don't deal with like terms. You actually have to do it to everything that's on that side. When I say both, I mean the left and the right side of the equation. So since on the right side of the equation I have two terms, then I have to apply the division to both terms. Now, in the previous problem, you only applied addition and subtraction to like terms. So if there's a non-like term, you don't apply it to it. You just apply it to like terms. Multiplication and division has to apply to everything. Kind of crazy how that is. But anyways, so I have negative 5x divided by 4. So I'm going to write this in just sort of my quick form here. And instead of actually dividing negative 5 by 4, I'm just going to go negative 5/4. And then I'm going to rewrite x as the variable in my term here. Okay. Now I know x was in the numerator here. So down here, when I change this to a fraction, I can write this as my coefficient. Negative 5/4 becomes my coefficient, meaning it's the thing I'm multiplying by x. It's just a simpler way. I don't have to keep x as a denominator now. Even if I did, it's still the same. So it would be negative 5x/4 or negative 5/4 times x. Either way, it's going to be the same. It's just more algebraic if I write it this way. So now I have 12 divided by 4, which is 3, because 4 times 3 is 12. Okay, so now I have put this into slope-intercept form. Now all I have to do is compare. So to find out if they're parallel, perpendicular, or neither, I have to look at just the slope. So my slope here is 4/5. My slope here is negative 5/4. Okay, let's see. The negative is opposite of the positive. The reciprocal, 4/5, when you flip it over, becomes 5/4. So it's negative reciprocal, which implies that it is, yes, perpendicular. If it's parallel, it would have the exact same slope. Like this is 4/5, then this would be 4/5. If it is neither, then it wouldn't be opposite reciprocal. It could just be any other number as long as it's not this number. Okay? So the answer is it's perpendicular because, I'll just put perp. It's perpendicular because it is opposite and reciprocal of the other fraction. Let's take a look at problem 3. What is the equation for a line that is perpendicular to y is equal to 1/3 x minus 1 and goes through the point 2, 4? Now remember in problem 1, we used the point slope form because we have a point and we had slope. Here we don't have slope, but we can determine the slope. The slope for this line is 1/3. We have a line that's perpendicular. The rules for perpendicular slope are, remember, opposite, reciprocal. Okay, so what is the opposite of 1/3? It would be negative 1/3. And what is the reciprocal of 1/3? That would be 3 over 1, or negative 3. So in this problem, the first step is to find the slope for the perpendicular line. So the slope for the perpendicular line is negative 3. So I can now substitute that into my equation. Now that I have a given point, just put the point in the right spot. Okay, my x value is 2. Now I know there's that tendency to say, okay, the left thing goes in the left spot and the right thing goes in the right spot. Don't do that. Put the x in its correct spot and the y in its correct spot. Okay, you have to look carefully at the equation. So now we have solved it. We're pretty much done, but I prefer it to be in slope-intercept form. Okay, so let's distribute into the parentheses here. Negative 3 times x is negative 3x. Negative 3 times 2, or times negative 2 would be positive 6. Remember, this is negative and this is negative, so negative times a negative is a positive. Now, all I have to do is isolate the y by adding 4 to both sides. Remember, when you're adding and subtracting, use like terms. If you're multiplying and dividing, it goes to everything. So my equation is y is equal to negative 3x plus 10, and that would be perpendicular to this equation. Oh, I just realized I've been off the screen for like ever. Should look more often. Okay, but anyway, so 6 plus 4 is 10. Negative 3x, just bring it down. So y is equal to negative 3x plus 10 is my perpendicular equation. Thank you much.